Good afternoon, everyone. Thank you for joining us. My name is Marissa Waterman, and I'm the Marketing Director here at the Academy. Today's webinar is titled WaterGPT, Tailored AI for Water Engineering, Learning, and Net Zero Strategies. Our Executive Director, Dr. Daniel Uther, will serve as a moderator and will introduce our speaker today. During the presentation, you'll be able to submit a question by clicking on the Q&A icon on the bottom of your screen. We'll do our best to address each question at the end of the presentation. Before we get started, Dr. Uther would like to say a few words. Dan, how are you doing?
I am fantastic. Thank you, Marissa, and welcome to everyone who's joining us live today, as well as welcome to those who'll be watching the YouTube recording years from now. We're glad to have all of you as part of this audience. It is a tremendous personal pleasure to moderate today's webinar entitled WaterGPT, Tailored AI for Water Engineering, Learning, and Net Zero Strategies, which is being delivered by my good friend, Professor Jason Wren from Princeton University. Before I introduce Dr. Wren in greater detail, let me pause and take a moment to offer thanks to the patrons of the Academy. Patrons are firms and utilities, including those whose logos are listed on our screen right now, who financially support the Academy. When you speak with folks from these organizations, please say thanks for their support of Academy programming. In part, through their generosity, we're able to bring today's event to our members at no additional cost. If you have an interest joining as a patron, or if you or your organization has an interest in proposing or sponsoring a webinar, please reach out and let us know. Marissa and I are here to listen to your story and to help to match your needs with the programming the Academy offers. And now, today's main event. It's my privilege to introduce Professor Jason Wren. Currently, Jason is a professor in the Civil and Environmental Engineering Department and the Allinger Center for Energy and Environment at Princeton University, one of the nation's and the world's premier institutions. He's very active on social media, and I encourage you to follow him there. The research by Professor Wren focuses on water resource recovery, decarbonization, and digitalization. He's authored more than an amazing 300 publications, a book, and he's even co-founded 2 startups with his students. He's received numerous awards, including from sponsoring organizations of the Academy, such as the Association of Environmental Engineering and Science Professors Frontier in Research Award, the Water Environment Foundation's prestigious Paul Bush Award, and the American Society of Civil Engineers Huber Research Prize. Also, Jason is an associate editor of the American Chemical Society's journal, Environmental Science and Technology, as well as ES&T Letters. As Professor Wren delivers his presentation today, I remind you that I have the privilege of moderating a question and answer event at the end of the presentation. So it would be great if you would share your questions in the QA panel so that I can use your questions to direct today's discussion. And now, with those instructions and introduction out of the way, Jason, my friend, the stage is yours. We are so excited to hear from you. Thanks for joining us.
Thank you so much, Dan. Hope you can hear me okay. So it's really a great honor to be here delivering this webinar. Thank you for the invitation, Dan and Marissa, and also thank all of you for joining this afternoon. I was told there's more than 200 people signed up, so really appreciate your time and your interest. So you all saw the title. It was a title that took me a little bit to think about because this AI is a big topic, and I was trying to think where I can be the most helpful, not wasting your 90 minutes of time. So you can also see 2 covers here from journal. I want to share with them because the first one is a special issues on data science from ES&T that I led, I would say a little bit more than a year ago, which contains quite a few very good articles specifically on AI and data science, how the people used different tools to help with research, technology development, and policy, and many other topics. So many of them are actually open access. So you're encouraged to, again, read them. The next one is a recent one earlier this year is also, I would say, a pseudo special issue by Nature Water on the decarbonization net zero strategies for the water sector. So that's also had some data science research associated with that as well. So again, you're welcome to take a look at that. All right, so before we start, I would start with a quick 3-question survey. If you would do me a favor, if you can bring out your phone, scan the barcode on the top using your camera, and the question will automatically actually pop out. Oh, somebody already started. Great, thank you. Or you can also just go to that website, Slido, and put in the number. So you can see in real time how many people are participating. And okay, very good. So that's sort of again give us a little bit background on I guess the sort of the background of the participants today, so we could certainly tailor my talk a little bit on the topic. Wow, we got okay, majority consulting. All right, thank you. Keep going. We'll wait for maybe 10-20 seconds. Yeah, it's easy. Just scan the barcode. It's automatically pop. Okay, I assume there's still some people shy or not want to do it. That's okay. All right, let's go to 60. Go. Come on. I haven't done that myself. So, anyway, so okay, we're getting there. So okay, so good. So we have actually pretty good mix. 40% from consulting, 35 from academia, and we got also quite a few utility friends. So thank you very much. If you would keep that, don't do anything. So next question automatically pop up on your phone or on your screen. Next question. Which tools do you use more frequently or generally in your work? I can explain while you are doing your answers. This one is a multiple choice. You can pick more than one answers. None? Seriously? Okay, so the first one is again a variety of large language models you probably already heard of. Then the geospatial AI tools, ArcGIS, very popular phase when you do like, for example, groundwork on pipelines, asset management. That's a fairly popular one, like Google Earth type of things. There's data processing tools for time series data for operational purpose. And there's certainly there's a general machine learning libraries, mostly based on Python. Okay, cool. So majority of folks use large language models. Oh, actually, surprisingly, a lot of people use geospatial tools. Other, none. Okay, very good. A good mix again. Again, hanging on there, just one more. This one is the last one, would need you to type. So you can just type in the blank, see what if you would have a wish list, what task you really hope AI can do it for you, like can be as dirty as possible. Like I hate my quarterly report to my supervisor, fine. I hate to edit manuscript from my students, fine. I hate to do the real time analysis of the bring my coffee. That's that's tough. Anyway, okay, let's keep going. This is fun. All right. Okay, you have to keep reading, otherwise we'll lose. Okay, flow data analysis, scheduling, timesheet, cost estimation, literary review, scheduling, technical questions. No hallucination, of course not. Data extraction, reports, articles, timesheets, cross sections, time efficiency, CAD, grading papers. I hate that too. Predict the future. I love that too. Okay, save my time. Cost estimate doesn't report. It does reports. Yes, I do that most of the time. Summarize. Budget management. Yes. Generate write-ups. Draw cross sections. Predicting power. Yeah. Well. Yeah, I would not trust that to be honest. But anyway, review paper. All right, we'll get to about 60-ish and then we'll stop. Okay, this is fun. We should do this more. Okay. Researching complex topics, personal schedule. All right, that's it. All right, so this is cool. All right, so one more. One participant is typing. All right. Okay, so you get the idea. Okay, so there actually a little summary there. So most people like the reporting side, the drawing, scheduling for you, drawing, right? And again, synthesize papers, right? So the literature work. So that's very cool. So okay, so now I'm gonna start my seminar. I hope you had a little fun. So 5 years ago, or actually even longer than that, right? As a researcher myself and a former consulting engineer for a few years before I became a professor. As an environmental professional, I put it this way, we always wondered like what topics the environmental domain is emerging, right? So 30 years ago when I was a student, if you're old enough, you probably remember the disinfection byproduct. DBT was a very popular topic, right? And nowadays, there's undoubtedly PFAS is the most popular one, right? Because we always evolve in terms of topics or the problems we face and we solve. So at the time, there was no ChatGPT, but there was a precursor tool called the natural language processing. So we started that you would call early AI research we did. So what we did was really, okay, can we develop some sort of customized data mining tools? Again, it's called NLP. To really mining the literature. In this case, we sort of analyzed about 20 years of publication from ESNT, about 30,000 articles to identify the history and the trend, and also hopefully to have some crystal ball to predict the future, what's going to come up, right? Because you sort of try to connect the dots, right? So that's basically what did. And that sort of this is again the baseline what ChatGPT or language model based off, like very basic skills they started with, right? So they had to group, right, what they call token. So they had to group, the words, right? I mean, before that, until like the GPTs became smarter to self-learn or reasoning. Recently, you probably use that fashion. They didn't know, right? So we have to come up with, okay, lead concentration versus lead is basically the same thing. Carbon dioxide versus CO2 as a formula is the same thing. So we have to tile machine how to do that. So that's sort of we call generally data retrieval and the pre-processing. That's a very typical process that people do. So you have excess component removal, acronym identification, replacement, all sort of other things. Then we developed this little algorithm, like how do we see the trend, right? The past and the current and future. So for example, you would have a numerator with the most recent year divided by the immediate past year, and how frequent this word, for example, decel, come up, right, over the year or the 20 years of time frame. And then you divide it by 5-year interval, by 10-year interval, things like that. The number you get 0.882 is exponential format. So you basically log of the ratio, meaning like 10 to the 0.882 means that this current decade, this word showed up 8 times more in average than the last decade. Means it's certainly getting more popular, right? So that sort of gives you the sense how we analyze that. And then sort of we also picked again the 50 and 1,000 the most frequent keywords that use ESNT articles. That's really also give you the sense, okay, the interconnections of the different keywords. You can see from the darker green to the lighter green is the frequency of the word. Water is the most frequent one, sorption, soil emissions, things like that. And then you can see the connections among them. For example, water is, say, clearly connected to removal, for example, right? Certainly you can relate to that. But most importantly, this is a sort of we hope to get a crystal ball at least to see what's trending, right? What's trending, if you see the diagonal line, the x axis is basically the keywords that actually showed up in frequency between 2000 2009, 10 years. And the y-axis is showing the most recent decade, 2010, 2019. This paper was published 2021, but the methodology is still valid. You can see most of the dots actually, the size of the dots actually represent how many papers were published using that keywords. So meaning the larger the dots means more popular in that case. Popular doesn't mean there's a lot of paper. You actually see the trend is more important, right? Most of the dots actually straddle onto the line, meaning that they consistently showing up. But you do see the trend, like you can see the red ones on the top, means very making sense, right? The PA chart said CO2 count, right? So that's very, very confirming. We know something you did maybe super if at least give me ideas where which area is popular, I can get more funding or what are more opportunities, right? Things like that, just simply put. Then you sort of also see the pearl change, right? Time series. See there's a change over the years. This is over. You can see different top through a life cycle, right? So you can see initially they may be popular, like MTB stuff in 2000, 2009. And then over time, you can see Fukushima, that was an emerging topic, a nuclear disaster. The microplastic getting more emerged and getting larger means more people study it. Then Fukushima fade down because that again is a one-time thing. And then microplastic kept its popular, right? Natural organic matter and those things keep its popularity, right? Then this is a graph actually drew my by my group member, actually a hero in this type of research, Dr. Junjie Zhu in my group. I call it a galaxy graph. You actually see there's 1,000 different topics, how they evolve over time. So just to give the little, you don't need to read this, but we actually have a website on this, and it's open access. You can do all the funds you want on this, on what topics are of interest. So beyond that, we also want to see, okay, what are the interconnections among the very different environmental domains, right? Water, wastewater, air, soil, solid waste, and many other things. So we sort of, again, do this data science, preparation, pretreatment, and also you have to have domain knowledge to be able to separate them out. That's one thing I want to highlight, because that's later on when I talk about language models, that's very important. Especially for our profession. So you basically see, okay, how the interconnections are. The blue crowd are the single domains, air, water, wastewater, soil, and things like that. And the green and the purple ones are the interdisciplinary papers, right? Paper may touch upon water and wastewater, touch upon air and water, right? Things like that. Interestingly, I can tell you, for those of you in academia, the intersection, meaning the cross section, interdisciplinary papers generally statistically get higher citations than the single domain paper. Not that the single domain are not important, but it's just you have two domains cite your paper rather than one domain, if that makes sense, right? Okay, so that sort of give you the very early background we did, again, prior to ChatGPT era. And then I'll get into the current thing, like what's popular and what we've done. This talk doesn't mean to teach how to use ChatGPT or Gemini. You probably better than me. And I don't claim by any sense I'm an AI expert. It's just a way we do research, hopefully to bring AI tool to tailor them, customize for our own water profession. So a quick little bit background, this may be all the confusing words. Most people just say, well, they are all the same. They are not necessarily the same, right? So AI is a broader field. It covers, it's basically an umbrella term, covers anything that people try to build like machines or system to mimic like a human intelligence, right? So it's not human, but it's a machine that's trying to catch up on us. And then machine learning is a subset of AI with all this algorithm with learning patterns to extract data. I would say mostly when you talk about machine learning, we mostly we talk about numerical data, but there's you can see deep learning and other data also included in there. So I want to emphasize, because I'll mention this later again. Machine learning, the key difference is this model is different from the models we learned in school. For example, we learned like active sludge models from IWA. We learned monodal equation. We learned microbial degradation of plastics or whatever, right? And you probably use a software called BioVin, right? Other things, right? So those are what we call mechanistic model. You have to learn the biology, chemistry, mass transfer to build up a sort of a mechanistic model to basically follow what the rule of physics or chemistry goes. Machine learning does not care. It basically say, well, I don't care what's in there. If you have enough data sets, data points, we just find a pattern. Then somehow we'll find, well, lower DO or lower dissolved oxygen will lead to certain failures or lead to certain energy use or lead to certain N2O emissions, right? So that's sort of the same how machine learning works, at least in our field. And nested inside machine learning, deep learning, it's just when the problem gets so complicated, multiple layers of neural networks, it gets into deep, right? And then it comes to, you can see there's a sort of branches coming out of natural language processing, where I just showed you the first example we did a couple years ago, and also this generative AI. And those are really not necessarily numerical. They actually include a lot of language, like how do we communicate like we are doing right now. And also the text message, the image, the video, the audio, all this other type of data that generative AI would be able to accumulate and create new content. That's what generative AI is, basically has its own brain. It come up with actually very new type of things, right? So that's what generative AI. And a language model, large language model, is just basically a small class of generative AI. It's basically the text. It's called language model. If you think of video, and Gemini is known like making very nice videos, right? Animations and audio, those are generally don't call language models, but it's a Gen AI overall. So my group does a lot of different things related to AI. So I will just give you an overview, but I'll focus a little bit on language model today. So machine learning has been around for many years, right? So we actually do machine learning research in the past few years before we focused on language model. So we actually do a lot of work. For example, I'll show you later in this specific example, we actually get the data from our utility partners. We actually work with them how to develop some machine learning models in conjunction with magnetic models to help with prediction, with risk management, saving energy, predict emissions, things like that. We still use NLP, which is actually larger than large language model, to actually looking into literature, reports, papers, and all the other sort of policies, and to actually looking into in specifically for greenhouse gas emission analysis, decarbonization work. And also we look into the AI tools or machine learning tools basically to help design better materials. For example, in this study, we try to develop a new type of membrane that have higher selectivity, for example, for organic acid. Right. So again, these are using different AI tools. It's not just all same. So in recent, I would say 2-3 years since ChatGPT, it just become our interest to actually looking into how these language models help with certainly our research, but also our profession for policy making, for operational utility, for consulting engineers, how to prepare different studies. So we published this ChatGPT and environmental research paper just a couple of weeks later of the launch of ChatGPT. It still remains the most read article in ESNT. And then we sort of trying to develop our, I don't want to say our own, trying to actually tailor some of the generalized language models like ChatGPT or Gemini for environmental domain or specifically for water domain use. I'll give you examples why we think this is interesting. I'm not, again, I only have like I'll say 1.5 people in my group really focusing on this, right? So I'm not gonna beat Google or OpenAI, but it's really, we try to tailor this for a specific niche application for our own use. And so that's basically things. So I'll give you one example, how do we use such tools for our research, and then I'll give another 2 examples how that used in applications with consulting and with utilities. Okay, so the first example I want to give is basically you know, with many utilities, municipalities, states, countries looking into the decarbonizing our world, and some industries already decarbonized, well on its way, like transportation or energy systems. Water and wastewater actually became emerging. This is the latest IPCC report. Actually, wastewater sector is the 2nd largest source of N2O and the 5th largest methane, right? So that's actually bring us to a large contributor of greenhouse gas emissions. And then what do we do? Well, why we are caring about this? You probably know, again, in order to achieve some sort of decarbonization measures, there's a timeline. Why is it 2050, 2040? And the time is not that much, right? So there's certainly, again, this is technical talk. I want to get into other areas. So if you buy your next car, it lasts for 10 to 15 years, right? So that means that like there's only one chance you change your vehicle to really reach the goal of 2050, hopefully to be net zero emission, right? But if you talk about wastewater technologies, like they last for more than a century. Think about this large, more than 120, 30 years old. And the thing is, if you have a technology that you implemented today, it turned out to be a questionable technology. For example, some technology people know can save energy, which is great. However, some other people notice that technology does save energy, but it leads to higher methane or N2O emission. What that means is the net climate benefits actually incurred in that technology may be neutralized or even worse in terms of climate benefits, right? So that's sort of in many cases that for us as a researcher, we want to get the bottom of this. There's a lot of risk involved in that. And again, this is the data talk. I won't get into much details on the emission side, but the complexity of wastewater system in terms of how much and where the emissions occur is fascinating. It's actually very complicated. If you think about the electric car, right, you only deal with what we generally call scope 1 emission. You don't burn gasoline, you get electricity, right? So that's basically the thing. Wastewater involves every aspect of emissions. So that's why IPCC had this one-shot gun approach, basically say, okay, they simplify this too much which there's a consensus in our industry and academia. IPCC made it's too simple. It basically say, okay, wastewater plants, you have this one emission factor and multiply by your population or by nitrogen concentration, that's the emission you have. In reality, it's really not that simple. And so you can see the reality is the different processes you use in the wastewater treatment, where you are located, how do you operate them, it's very much depends on the different utilities that leads to very big differences in terms of greenhouse gas emissions. So that's why we did this groundwork. We actually work with Professor Dandolo, is actually my office neighbor at Princeton, the air quality expert. So we drove around, again, more than 100 plants in North America to look into all these real emissions. And what we found is the actual emission from these plants are far from reality that IPCC tells us is. IPCC tells, okay, this is the number that you should use on your, for example, inventory or greenhouse, how much emission you have. But the actual emission is far from that. It can be 5 orders of magnitude different. It can be lower, can be higher, but majority higher. But the average is about twice of the actual emission compared to IPCC tells us. So what that means is that we really need to get into the nuance, individualize our own emission. Otherwise, you will be either penalized by the EPA if there's any regulation, or actually you would not actually getting into the benefits of reducing emission. So the reality is we cannot drive by or drive through every plant every month, right? That's not possible. So we use AI in this case. It's language models. So with the data collection from all the literatures possible, more than 300,000 related publications. Then we had to do data extraction. We had to do pre-processing. We had to do fine tuning. And those are the details. How do you use a model? And then we develop our model, and then we fit into the database because you have to get nuance, different technologies, different in terms of emission, different process, different operation, again, very different, right? Then we fitted this into the EPA Clean Water Needs Survey data, 2022-2012, because that tells us what technologies each plant use, where they locate, how much water they treat, what organic loading, nitrogen loading they have. Then we put our model into the data set. We have a Monte Carlo analysis doing sensitivity. So we then be able to dissect, okay, what are the variations among the different measurements technology, among the different processes people use, among the different flow, among the removal rate. So we're able to enrich this data by more than 12 times as what IPCC used to come up with regulation. So we say, IPCC, this may be more comprehensive for you if you would do the next regulation. In the meantime, it will help utilities and consulting engineers to look into the, again, the details of each individual plants, right? And so that the model also allows you, okay, which methods and which technology actually have higher emissions than the other, and where actually we'll see can be risky and can be implemented. Again, this is a data talk. I want to get into that. But all these papers are open access. You're welcome to read if you're interested. Similar idea applies to methane emission. So the interesting part is you may say, well, how do I trust your model is correct? Coincidentally, that our model, without really checking with Mark Zandolo's group on the field, he did his groundwater on real-time monitoring. We did our data science measurements, right? Data science analysis based on existing literature, which are based on actually real monitoring by other people, right? Think about crowdsourcing of the data. And this is all published peer-reviewed articles and conference reports, so that's again trustworthy. So so interestingly, we found very similar. So we found about nearly twice of the actual emission based on the real literature data, as compared with IPCC or EPA in this case too set up. So that's sort of indirectly validated. Yeah, this approach does help, right? So you don't need to monitor every plant to come up with for the policy making, right? In that case, but for individual plants, that definitely helpful if you could measure. Why is this study is helpful? Why is the language model is helpful in this case? Because as of January this year, you can see the date in there. That EPA was basically assembling the latest inventory of greenhouse gas emission from each industry. So they actually made notable attention on our recent work to actually help them to reevaluate and set up a policy, right? And you can see, I'll give you another example where this thing is important is California. So this is a mass emission distribution this is figures by EPA, but what California Air Quality Board, CARB, did, and they did a lot of studies working with local utilities and in California, and you can see municipal solid waste in terms of methane emission is about 11% at the time, and wastewater about 7%. And that was based on the previous analysis or previous data, let's say EPA, IPCC analysis. With the new data, it's double, right? From both ground study and literature study, and certainly confirmed with some other study. If it's double, it's definitely not 7%. It's maybe, I don't want to say it's 14%, but certainly at least at a, I guess, a similar level of municipal solid waste. What does that mean? That means if this something is may actually get to a regulational consideration if really the emission can be significant, right? So that's sort of the things. As a researcher, we just want to get the ground truth, what's happening in there. We'll help the industry to make the best of the data. And also, certainly, we can inform the policy what the science tells, right? All right, so related to all this effort, so I'm involved in multiple projects actually funded by Water Research Foundation in collaboration with several partners from Ron Coldwell, Jacobs, U.S. Water Alliance, and many others to looking into the decarbonization and helping to build up guidance and inventory for the wastewater utilities. So that sort of give you this little sense. And also, I want to, I don't want to say I ask another favor, but there's a, I do, in fact. If you are a utility or consultant, and if you are not aware of this survey ongoing, I know many of you probably know already. It's still ongoing survey. This is in collaboration with partners at Berkeley Lab, Water Research Foundation, and consulting companies to really build up this database. I mean, whatever AI tool you use, you have to have the data, right? The very common way we saw garbage in, garbage out, right? If you don't have quality data, you cannot trust the tool or the AI, right? So that's the thing is, we hope to collect the data and talk to you to see what you have in terms of inventories, in terms of operation, in terms of energy use, in terms of emission stuff. And we promise we will not share the data with anyone, and all the data will be anonymized. And what we will get back to you in return is we'll actually share with a report. We'll try to build up some guidance or summary and sort of mitigation strategies we'll share with you to help you. I think what other utilities have done may be helpful, right? And certainly we hope to build some tailored AI tools later on to help you to predict, to mitigate, and to operate, right? So that's, again, a specific case study. You can see how do we leverage AI tool and with the data to benefit the society. All right, come back to the language model. So the next example is a little bit more research oriented. So I'm not in a position to really compete with ChatGPT or compete with Google, right? But probably most of you have used or tested some of the models from the different companies. And you can see over the very fast in the past 2-3 years, the language models have matured or getting better much fast. If you think the first ChatGPT released 2023 was like a high school student type of general knowledge sharing, and now it's actually getting into the PhD level in certain areas, right? So from a very shallow sort of generalist to with certain knowledge of domain expertise, but still in many cases it's not good enough to solve our specific problems, right? So that's what we are trying to do on that end. And you probably have experienced this 5 stages of I call it 5-stage mastery. You say first of all, you say, wow, this is super cool. When I ask ChatGPT, okay, where I can find the best ice cream shop in this town, it tells me, right? So I don't need to Google around to find other people's answers. It's very direct. Then you feel, oh, the address is wrong. I mean, I went to the wrong place, right? Then you say, well, I don't want to trust it anymore. Hallucination, what you call, right? And then it's getting better and better. Nowadays, I have to say my best practice is, you know what? I actually asked at least 2 different models to cross-checking them. So make sure at least they have similar answers. Yeah, I would trust that better. So I think probably many of you use the same way. And then there's certainly there's benefits. It helps us writing, literature work, finding report, and programming, right? That's the most common use. And certainly there's a lot of challenges. The answers may be wrong, right? It may not give you the exact answer you wanted, and you need a lot of prompt engineering to do that, right? Things like that. So let me give an example why we work on specifically what we call fine-tune these models for our profession, what we all call WaterGPT. I'll give you an example here. So this is a little bit more expert level question, right? So activity sludge model developed by IWA, right, is a magnetic model, right? So it's basically you have to understand all the kinetics, thermodynamics to build up the model. Quite a complicated model, right? And I asked, set up the ground, right? So then the question is, what's the most important compound to be measured to evaluate the model? Like which single one? And at the time, this is about last year, so we asked 3.5 and GPT-4, so that's the answer. 3.5 gives us the concentration of organic matter. 4 give you the answer is basically the suspended solid itself, right? And at the end of the day, they are related, but they are not necessarily the true answer. The textbook answer is oxygen, is the most important one in this case, right? So that sort of give you the sense, well, they can give you relevant answers, may not the right exact answer that is accurate. Especially get deep into the domain knowledge, right? So then we're saying, well, there's anything we can do to help our profession, right? And why this domain specific model can be helpful. And what I mean is, first of all, these models are open source. You don't need to pay. And also it's transparent, meaning that anybody can contribute. And certainly there's a auditability, like whether it's right or wrong, right? So it's open source, right? So that's sort of the things that bring the community together and give a higher trust. I mean, you can trust ChatGPT 100%, but others may not trust them single-handedly doing that, right? Or OpenAI, what I meant, right? And then basically because it's open on domain accuracy, it's very trained or fine-tuned, specialized to actually for our own use. And more importantly, for utilities, you may say, well, you don't want to upload your data to OpenAI or Google because you don't trust them, right? And many of your utility I've known, at least my partners say, well, I'm not even allowed to actually go to the cloud. It has to be local server, right? It has to be my own computer. What that means is this smaller model, basically, they don't tell you where the weather is, but it tells how to solve your specific water operation problems. It can run on your computer. It's a small model. It's a domain-specific model. It's secure. It's actually keep your sensitive information under your control, right? And you can fine-tune it, you can customize it, and certainly things like that, right? So there's certainly certain niche use for some models like this. And we are not alone. There's medical-based model. There's basically legal models. There's a financial model. They actually, each company or each domain is developing those things too. So what our research been working on is basically we actually trying to figure out how to make this model more tailored to our own domain, right? Our discipline, right? So there are two general approaches to do it. One is called fine tuning, where you basically you embed the domain expertise directly into the existing model. And the other is called a RAG, it's called a retrieval augmented generation. It's basically you have a up-to-date facts on demand. You don't need to learn everything. To put it simply, if you say fine tune, it's like you're a very good student. You come to class every day, you do your homework carefully, you do your exam very carefully. So every knowledge or skill you learn during the semester is internalized into your brain, right? And then you go to the exam, and then you basically getting that answers out of your brain. And then basically that's what fine tuning is. Then we'll say in many cases, well, the question is not necessarily the answers. How to say you don't know exactly the answer of some exam questions, but you are able to tailor your questions, your answers to that question as close as you can, right? That's sort of called fine tuning. RAG is more like a different approach. It's like you sort of hung out with your friends a little bit more. You didn't go to class very frequently. You are not very actually careful on your homeworks, but you had 3 days. Then you had to really emergency. You get all the books you can get, the library you can get, knowledge you can get. You have 3 days to pick and choose the knowledge you might need for preparing your exam, right? It's much more efficient. You may still get an A if you're smart enough, you're a good researcher, right? At the end of the day, your outcome is still good, but it's not very systematic. But the good part is it's super, right? You don't need to redo whole semester of class. So there's a pros and cons. So we are doing both. And right now, I just show you one example. We're doing fine tuning the old way, old-fashioned way, right? So we chose 22 books, open access book from IWA. And we sort of have this base model API from GPT or Llama 2, and we fed this book information by actually we have all this we break them down into tokens, into hundreds of tokens or phrases to basically train them to let them accumulate this domain knowledge from the book rather than the generalized knowledge like ChatGPT may never read biological wastewater treatment, to be honest, right? So we fine-tune this model, and then we design 300 plain QA questions to basically test it. Then we have human expert, basically my PhD students. And then they will basically evaluate whether actually which one at a certain quality, what's the quality of the answer, and whether it's actually relevant or factual, right? So that basically what we did in this case. And so basically we compared, first one we fine-tuned with the base GPT model, and we sort of modified it. Then we have fine-tuned GPT with incorporate this 22 books of knowledge to make it to answer the different questions, right? So hopefully they will pick up some of the difficult questions correctly as other than base model, right? So in that case, you can see there's a levels of difficulties actually the GPTs can answer or the models can answer. You can see the X is relevance, the Y is factuality. You may say why that matter. Say, let me give you an example. If I ask you, okay, is it gonna rain tomorrow? Right? And your answer is like, well, there's maybe 70% of rain and things like that. I mean, that's the direct answer, meaning it's a factual and it's very relevant. However, if you tell me, okay, it's gonna be 75 degrees tomorrow, it's a factual, but it's not relevant, right? So sort of give you the thing, or you may say, well, it's gonna rain, but it's not in New Jersey, it's gonna be Alabama. So it's not relevant. I mean, it's relevant, but it's not related. It's not factual, but whatever. So I think so. You get the idea, right? So depending on the difficulty of the question, say most actually GPTs were able to answer wastewater treatment development question because that's relatively easier. But if you get to much deeper, like nitrogen removal, like NMAX, whatever, deeper domain knowledge, they are less actually factual and less relevant. So go back to the same question I asked. Again, which is the most important compound, right? 3.5 or 4 give the, I would say, relevant and factual, but not that, I would say, not in the high accuracy, the right answer, right? And you remember how oxygen was 1. So through the fine tuning, again, we did not designate its answer. Okay, trust me, we did not actually cheat, right? So we basically let the ChatGPT basically to learn from the 22 books again, and then we fine tune it. So it's actually with the fine tuned model is able to pick up its concentration of oxygen. Good, right? I'll give you another example, right? Same thing. So what is the source of organic carbon metabolized by phosphor accumulating organisms, right? EPPR system, right? So PAO. And the answer from the textbook, classic textbook, it would say, well, it's a hydraulic fermentation from recycled actually sludge producing this soluble organic carbon, like a VFAs, right? So if we ask ChatGPT 4, it's really very close. It's a metabolized organic carbon derived from wastewater itself. It is true, but it's not specific enough that would give you the exact answer, right? So after the tuning, you can say, well, it is actually the organic carbon from the fermentation of the VFA. So to give you the things, I have to say that answer is not strictly accurate as well, because it's a VFA produced from the fermentation. It's actually not the fermentation VFA. But anyway, and some VFA can be fermented too. So anyway, I want to get in detail, but it's getting better. Just to give you a little sense, how do we tune to make the GPTs better for us? There's a lot of work to do, right? So again, if you maybe one day the the GPT 05, 010 or DeepSeek R5 gonna be much better for in general. They grow so much, right? So you can see they are much better than before. But the open source model has been lagging because there's not much resource. I mean, they got billions or tens of billions of dollars, right? I got nothing. I just for self-interest, right? So really the case is we would have actually leveraged the improvement from the existing models to basically tailor into our own use for this language model and hopefully to share with our community to help with the operation. All right, so I'll give you one last example. This is sort of a hybriding the language model with other tools, right? So in this specific example is with machine learning model. Like I mentioned, and this is actually a case study with clean water services in Portland, Oregon. And thanks to the partners there, they have an issue, right? So in Washington, you have, in Oregon, you have this wet weather event, a lot of rain, and you have dry weather, right? So you don't have rain like in many months, right? But the issue of the plant is they have a dynamic sort of a permit system or discharge permit to the river. And so they have a say 3-day average ammonia concentration, 7-day average, or 30 days, then have a daily limit. It's very complicated. And the issue is when there's a wet weather event, when there's rain, the water gonna flow into their plant, and because again through the the wastewater pipes, and then it's gonna dilute their treatment. They have to change their state points, right? If you remember in graduate school, state point analysis was one of the most difficult part of the class if you do biological treatment. I still remember those days you have to draw this and calculate using a ruler to draw this, right? It's very complicated. So nowadays, people still use like a human expertise and estimate using weather station to use your basically experience to predict what's going to happen. So the machine learning the machine learning tool we actually developed together with Clean Water Service was really we get their historical data. Basically, the how we have also about 100 years of weather data. Basically, how much rains are put into the river, then related to how much river water getting into their plant. Then how do they actually get into adjust their pumping rate, their MLS actually concentration, and change the curve, right, on the secondary clarifier, right? So then we developed this model to mimic, so we could predict the future flow. If you say, oh, there's gonna rain in the next 3 days, and then we will predict how much water will likely enter into their plant, and you can see the model worked pretty well. We actually have nearly about 1,000 different sort of comparison machine learning structures to see which one was best fit. And then we were able to predict this. And then we work with Clean Water Service to basically have better focus. And then credit to them, they developed the Power BI dashboard to basically help with, again, modeling and actually helping with setting up the pumping rate in advance without actually violating their permit, right? So that's sort of the things give you the sense actually how this machine learning tools are being used into the reality. And this work certainly mostly I have to say credit to Junjie and engineers at the Clean Water Service. We won the first prize in the Intelligent Water Challenge a couple years back. So then you'll say, well, there's so many tools. How do we actually better use all this, right? So this is a hypothetical, right? So right now, there's a lot of efforts on the machine learning side, right? So it's a data-driven model, as I said, agnostic, because we have so much data, time series data, right? Spatial data from the utilities. You can predict and you can basically use a pattern to get agnostic analysis. A better way is you can actually connect that with magnetic modeling, like BioWin, for example. Then you can have hybrid modeling to give the digital twin to help you to better do all the different analysis, whether scenario, variable, process control, decision making, other things. The issue of this is talking about a workforce training. not everyone would be comfortable doing this machine learning things. Hey, I never learned Python. I don't know how BioWin works. I have to say, when I did the BioWin training, I had to get like 5 hours of training with actually their company employees, how to use this, right? It takes a lot of effort to learn this, right? Then what comes to language model? Language model is an every person's model. That's why I love it. I want to work on it. First of all, the language models is a textual. It's a human language. It's not a 0 and 1. It's not coding, right? It actually can automatically change your words into codes and then put into machine learning model. How good is that? You don't need to know Python at all, right? So that's the things you could also get you more textual data that before other models cannot do. Other model can only do numerical data, right? That also make your model much better. And then you can have prompt, you can have command to that. And then the output, you actually then have this domain models I just showed you. Through the fine tuning, you actually give a lot of nuance, specific expertise into the digital twin that make your analysis much more accurate and trustworthy. And even better, actually many of you responded that it actually can help to come up with a report. It helps with analysis, give you the report and all the logs and so you don't need to analyze it by yourself. So that's why when you have these different models working together, that's the ideal scenario for us, right? So I don't have a model for this, and it's gonna take many years to do this, but I'm sure we'll get there someday. So I'll give you one example. The most hot topic you probably heard is called AI agent, right? So AI agent is basically your personal secretary, your personal agent can do a lot of things for you, right? So this is the most recent event by Google. Sundar Pichai actually showed this personalized email reply
AI-powered smart reply features. Now imagine if those responses could sound like you. That's the idea behind personalized smart replies. With your permission, Gemini models can use relevant context across your Google Apps in a way that is private, transparent, and fully under your control. Let's say my friend wrote to me looking for advice. He's taking a road trip to Utah, and he remembers I did this trip before. Gemini can do almost all the work for me, looking up my notes in Drive, scanning past emails for reservations. Gemini matches my typical greetings from past emails, captures my tone, style, and favorite.
Oops, sorry. Anyway, you got the idea. Well, somehow it's so. So you get the idea that now Gemini can access all your computer, your laptop, your computer resource, know how do you actually write your writing style and your information before you itinerary 3 years ago, then write a personalized email back to your friends, right? So that's really, it's a little bit scary, to be honest. Like the friend may not know which one is from Gemini, which one is from you. So, but that's what AI agent can do. You have to trust them anyway. So then sort of extrapolate from that, right? What kind of imaginary WaterGPT looks like? I don't have, you may say, well, I have a WaterGPT you can use. I don't, to be honest. But what it can do for us, and it takes time to do that, right? I mean, there's certainly credit to ChatGPT from both the logo and the ideas. It can do real-time process optimizer, right? So you have a time series data from SCADA. It may actually help you to analyze what's happening to optimize your operation. Right? And the easier one is regulatory, right? Many consulting engineers would say, what's a compliance report, right? The local, the state, the federal rules and the design protocols and sort of things. It can help you with that. Predictive maintenance, right? There's a sensor data. You can say, oh, there's going to be a failure of this valve or this pump, help you testing. Asset manager, a lot of financial data, a lot of, again, infrastructure management, right? Demand forecaster, like a water meter and leaking and many other things, right? So that sort of gives you the sense there's certainly imaginarily, there's a lot of things we can do. So anyway, so you get the idea on that. My last slide, I do want to thank my group members at Princeton, especially Dr. Junjie Zhu, who is instrumental in many of this work, and also my funding agencies, Princeton Language Intelligence, it's an internal program, Ellinger Center as well, DOE and Research Foundation. If you have any questions, feel free to email me, or you can scan the LinkedIn page to just make connections. Thank you so much, and I'll yield back to Dan for questions.
All right, fantastic, Jason. Thank you so much. I'll get you to stop screen sharing, because then that way it pops up for folks and they can find it easier. Sometimes it's nice to kind of see a little conversation back and forth. Awesome presentation, my friend. Fantastic. I'm going to use the same format that I regularly use. I got some questions that came in from the audience. I got some thoughts in my own mind. So maybe let me just kind of lay out what we're going to talk about, kind of, start to finish. And then as we go back and revisit them kind of item by item, we can pick them up and kind of talk about them. So going back to the overview, great tool to get some input from the audience. Kind of fascinating. 25% of those that responded said, I don't use AI at all. So we'll come back to understand, what that impression meant to you. We'll come back to that. There were some folks that asked for more details about some of your articles. I did drop the DOI link to that particular review in chat, and I did also drop your Google Scholar link in chat. So folks that are looking to follow up with your work and all that you've referenced there, be able to find that. You then got into understanding some details about artificial intelligence and how it works, right? And so you had a nice Venn diagram. And so some folks were asking questions about so where does statistics fall in, right? It's kind of like we think about mechanistic models, we think about engineering empiricism, we think about statistics, we think about AI and large language models. So we'll come back and talk a little bit about those roles of some of those different terms as an engineer, as a data scientist. A question in this space, though, is also to understand, you mentioned GIGO, garbage in, garbage out. How about malicious data, right? Are these approaches safe, or are there people out there that are maybe intentionally corrupting existing data sets? And should we even be worried about that? So something to think about. You gave us a nice application to climate, and you did a great job talking about kind of life cycle and thinking about the investments that we make now and how long those are. And that was a good justification, particularly for the studies you were thinking about with wastewater treatment. And so we had some specific questions in there, very, very targeted, right? Is there actually now enough existing data and analysis that we could actually have air emission regulation for wastewater treatment facility, right? If you crystal ball it, could we actually do that now, or is it still kind of far off in the future? So we'll look at that a little bit more. You talked about the local WaterGPT and how that works, right? And so some questions in there ran the gamut of, well, isn't this just a fancy version of Wikipedia, right? What is different about this being an AI model versus just going to the textbook myself? There's expertise that humans have. Humans have been able to think about mechanisms when we didn't have data and we were past empiricism. Think about Einstein, thinking about relativity. Not a whole lot of data, not a whole lot of empiricism, just a whole lot of human thought. So where does AI fall in that? Can it do anything like that, or is that completely beyond it right now? Can WaterGPT be used to assess simulation models? Which ones are right or wrong, or why? Particularly water distribution systems and groundwater fate. Do the models learn from their predictions? Do they iterate, right? Is there bootstrapping involved in these models? So we'll talk about some of those kinds of things. And then maybe some more practical questions, right? You talked about workforce. So if you go to a facility and you watch a drinking water operator dose coagulant, they know what they're doing, and they somehow they're like, we're going to adjust this. Or you watch a operator run a belt filter press and dose polymer. They just know what they're doing. So where does the role of OpenAI fall in supporting operators who are experts and just have this gut sense about what's going on? Where does AI fall into that? And then for teachers, okay, I'm really worried my students are going to use AI and they're going to get the answers to all the homework problems or answers to all the questions, right? So as an educator yourself, how do I deal with that? Do I forbid it everywhere in my classroom? Is there some good way to teach with it? So we'll unpack a little bit of that to kind of the teacher space. And then of course we'll end with what's your words of wisdom for those out there that want to get more engaged in this, that want to learn it some themselves. What would be your advice for how they get started? So that's the kind of stuff that we're going to unpack. We'll go about and pick them up kind of one by one. Let's go back to this initial interesting result. So at the time of your survey, there were 110 participants. 60 of them did the survey. 25% of the respondents, or 15 people, actually said, I don't use AI at all. Any initial thoughts on that? Was that surprising to you? Or does that have any, is that kind of across your experience, or?
That's why they are here. They are interested. They want to know how AI can help, right? So I would take that as a positive sign. I think people use AI in their daily life. I probably, as long as you're online using your laptop, you're probably using some AI tools already. You're just not, I guess, not aware in many cases, or your definition of AI may be different. You not necessarily you have to have to use modeling or programming or things you feel like AI. I have to say for folks have not really tried these tools, at least what I showed today, I would highly encourage you to give it a shot, because you will be amazed. Dan is nodding. You'll be amazed how powerful they can to help with your life. I'll give you one example, just a very simple example. My son is a rising senior in high school, right? So I'm planning for a college tour trip for him. I'm gonna drive from New Jersey to Boston, and I know there's quite a few schools, right? Traditionally, I had to search, oh, which school is where, how do I plan for my stop? Where do I stay? Where the admission office is? I mean, and now you just put your needs to ChatGPT or Gemini, boom, it's actually come up with a spreadsheet for you. It's actually so easy. It saves you 2 hours, right? So that's the most easy way to use AI right now. And not to mention like helping with your writing reports, things like that. You will be amazed how helpful that. Then related to again, how I think there's a Professor Mason asked and some others like the trust side of AI, right? I mean, we all have doubts, right? I mean, I think Dan had a very good point when we chatted before the webinar. It's to treat AI as a hypothetical person, right? And it takes time to build the trust. And you may know, I mean, think about it, it is a very smart and knowledgeable person, right? Maybe and then you would ask it questions, right? Sometimes you get right, sometimes you get wrong. I mean, so it takes time to build a relationship, I'll say. And then over time, you say, oh, this area, I may not want to, listen to this person, or I will have my own judgment, right? Or he got it wrong, right? So then that's what I'm saying. What I do is I cross-check. At least I used to, if I have any doubt on the answers, I'll use another tool to cross-check. Because trust me, they are competitors. They don't share code from me with each other. So if both get correct, I think the accuracy is pretty correct. Pretty
Fair enough. So now you helped us try to understand AI. You were talking about the difference between AI and language models. You had a nice Venn diagram, kind of where all this stuff falls. Now we think about this as engineers. We're accustomed to the empiricism of engineering and our gut feeling. And hey, because we look at kind of, the amazing work from thousands of years ago, whether it's the Egyptian pyramids or the Great Wall of China, right? Like they could do all that without calculus somehow. So what do we need calculus for, right? So I say this tongue in cheek because of course students would ask us that, right? So machine learning, the way you seem to present it, and AI, the way is it seems to be that it's correlation as opposed to causation, right? It works because there's huge amounts of data. So what's the role of statistics in that? If we're thinking empirical on one side, we're thinking mechanistic on the other, and then we're thinking just mounds of data and AI working in the middle. where does the role of statistical models fall, mechanistic
Yeah.
models, AI approaches?
I have to say statistics is a core value of the machine learning models. You have, I mean, you would say some people actually blur the line that statistic is also finding the pattern, right? To a certain level. So machine learning very much rely on the pattern, right? So if you have this pattern, I would think that may lead to the consequence what it looks like, or they have a pattern to predict what's going to happen, right? Machine learning is very much use prediction. That's so statistically sort of in that level is very much actually similar in that case. Machine learning is just more sophisticated. It has multiple layers of input, output, and thinking beyond the statistics. So they are not necessarily exclusive from each other.
Makes sense. But we always teach our students, right? The first statistical tool is just graph it and then look at it and see what you see, right? So
Exactly. Yeah.
makes sense. Makes sense. Okay, so in this space, then, when we're thinking about these, we're putting in more and more data, right? You mentioned GIGO, garbage in, garbage out. So you kind of offhandedly mentioned, well, I'm grabbing this data from peer review or from conference proceedings, so we can we can kind of trust it. There's the publish to perish model out there, which might bring some question of trust in there, but now we are relying on these more and more to kind of do parts of our work. We can start to imagine malfeasance. We could start to imagine whether it is competitors or state actors seeding with wrong information, people making wrong turns, and then that reinforcing others to make the same wrong decision. Groupthink of bad decisions, which more people think is the right answer, so more people pile on. So, what are some of those constraints or concerns when we're thinking about AI?
That's a good question, and that's a tough one. To be honest, Google, Facebook, nobody figured that out, right? So, uh, to me, yeah. First of all, like you mentioned, you at least for us doing research, the data needs to be as high fidelity as much, right? So that's why we started with peer-reviewed journal articles. We generally trust them. At least they went through the expert screening, right? So that sort of help. Textbooks that generally again went through levels of screening and also at least written by experts, right? And it's out there, the reputation risk in there. If you publish a book that is wrong, right? That's your name is the Philip is of forever, right? So that's why we're all careful, right? So that sort of level of, I guess, guardrail that we use those data. At least for in our domain, it's probably not worth the state players or other people to fabricate false data to actually I say want to damage the AI. Plus, the AI has so much rely on so many data points, and there's a training set, there's verification, there's others or iterations, fine tuning stuff. It may not be that easy to alternate the truths, I have to say, if you would generally have a good data set. With that said, though, it is a very big risk, and that's something we have to be aware all the time, whether you have a trustable data. Related on that, Dan, that I think you mentioned also the how big is big enough for you to do AI tools or machine learning tools. There is no actually a rule of thumb, like you have 100 data points that you probably won't be able to do that. At least a couple thousand, then people would argue, well, you can still just draw statistical graph, you can do that, right? So this at least to have I guess thousands of data points, and also the different what we call features. Features mean there's a ratio between the data and the feature, means like, okay, it's the temperature, the pH, and there's a multiple parameters related to that. So there's a ratio. The ratio generally called rule of thumb is 10:1. So because you don't want to, for example, time series data, you can say, well, I work with a treatment plant. Each day they got 500,000 data points. It's all redundant time series data, day after day, right? And if you have like 300 days of this repeating data, that does not mean much to us because you don't have the variability, right? I mean, if all the same data is junk data, you only need probably 2 days. That's enough. right? So again, the size of the data set, it may not be that critical. It's actually the variability to allow the AI to work, to find the pattern, to make the prediction, right? So that's more critical.
Yeah, makes sense. Well, and just to follow up on that one, right? Because of course, from a statistical standpoint, we would assume a degree of data independence. But as you're pointing out, right, 300 days of time series with 100 series every day, very little of that is independent, right? I mean, it's all the same
Exactly.
plant, it's all time series. So even when we apply statistics to those kinds of data, we really are doing it with a little bit of kind of, not really paying attention to some of our rules for statistics. So good points that you're raising there. We might be fooling ourselves when we do it by hand, thinking that we're actually doing a good job.
Right, exactly.
So you talked about some applications to climate, which was really good. So we had a couple of very specific questions from some of our audience. I'll just kind of read those verbatim and let you kind of address them. But does it appear that there's enough data to support some draft air emission regulations for wastewater treatment facilities? Can you feel comfortable to speculate on that?
That's a sensitive one.
We'll
I
turn off
think
the recording and then
I'm not a policymaker. There's existing regulation. I don't say regulations, guidance to policies, understanding on what the emission looks like. And it's really up to the regulation agencies to think how much data is enough. I guess what matters to my work as a professor is like what do we know with the data we have and what is the gap of knowledge in there? Do we have enough knowledge to see this is say how much emission in there, or should we do something for the utility level? And I'm not making decisions. I'm more informing in that case, right? So the person does have a good point. Like, do we have enough data to do the AI? Exactly, like go back to the last point we made. It's so we that's why we are sort of using this sort of double checking or cross checking approach, right? So we do ground actually monitoring ourselves. And then we complemented that with existing literature data where also true measurements from other either utilities or research groups and things like that. So we sort of complement the data set to reach to similar conclusions that give us much higher confidence this data do make sense.
Makes sense. Makes sense. Second question we had kind of in the same space, and this is going to be a trickier one, still a good question, but given everything that's gone on, and we'll stay away from policy and politics discussion. Well, I'll ask the question, we'll try to answer it here, but what impacts have you seen on greenhouse gas and climate change research and related funding, given the role of AI? And now we'll stay away from the politics side, right? So let's assume, but what role does AI have in being able to do this kind of research, particularly in climate and greenhouse gas? If somebody was going after funding, should they collaborate with folks using AI? Like, how do you see it playing out? And again, we'll stay away from the politics, but how do you see AI's role in this important space?
Um, that's my pain point right now, Dan.
Understood.
How do I say? There's pretty much very few opportunities on federal level on climate research right now. How AI gonna help it? It's really in a way that there's a very powerful tool that enable better climate research. Um, I cannot make the comments whether that's gonna help with the fundraising, to be honest. I'm myself in that question mark too. But it is to me, that's why in the past few years, at least in the past few years, that were helpful. So let me put this
Fair
way.
enough.
Yeah.
Well, what if I also couch that question a slightly different way? How about the role of AI in updates to the IPCC reports? Do we see that AI is growing importance? Yeah.
Very much. Just to go back to say, I showed you the slides like like EPA start to pay attention on the studies, because I can give you one example why I don't want to say AI, but more data in general and the tools in general help IPCC setting on policies. they set up a emission factor, a number, to our whole industry, say N2O emission, right? Your N2O emission is this number. If you have this many population, your nitrogen concentration like this, right? And that applies to every utility. We talk about tens of thousands, 100,000 across the world, right? And that number is based on 30 studies, 30 papers. That's it. And that's why our nature sustainability paper says, look, this 30 papers not necessarily represent the reality of the actual emissions. So I don't think that one number are going to represent the truth, right? They're going to have a lot of implications on the ground, on our utility operation, our consulting work, on policy making on the local level. That's why we actually enrich the data set by at least one order magnitude based on existing data. We also give us dissect into the different technologies, different size, and many other parameters that IPCC did not consider, right? So that sort of, again, gives them the information so they can do better policy making that also reflect reality, and so our utilities can have a voice on that as well.
Awesome. Makes sense. So then we had some questions that are now getting into this local water GPT, right? So a specific question, could this be used to assess results of simulation models such as groundwater fate and transport or water distribution system analyses? You gave us a few answers, you gave us a few examples, you know, ASM and thinking about EBPR and things like that. But how about groundwater fate and transport or water distribution system analyses? Are there parts in there that are already being incorporated?
I don't know exactly what models have been developed, but that's traditionally has been very model heavy hydraulic modeling area. I will be surprised if there's no AI model or forms of developing that, right? So I'm pretty sure there would be, but to be honest, I'm not in that specific field, but there would be. Yeah, take a look, take a search, I guess. Yeah.
Fair enough. Fair enough. And then how much modification will be required to change the wastewater flow prediction model to learn from its predictions, whether it's supervised or unsupervised?
Generally, you would probably start from supervised. I sort of give you more control. In that case, it's pattern recognition and things like that. And mostly, actually, the wastewater flow is not that complicated to actually have to use multiple layer unsupervised learning. That's my personal take on that. Yeah.
Fantastic. And then how about from an operator standpoint, right? You know, some of those operators, with the way they dose polymer when they're running a belt filter press, or the way they're adding coagulant when they want flocculation, it's like they somehow just kind of, they look at the way the clouds are or the weather is, and they go and they make a dose and you're like, wow, they know what they're doing. So where's the role of AI in that? Is AI even beginning to enter that space, or?
I would think AI probably can that sort of links to both hardware and software together, right? Robots and the AI. It's probably I think if we're gonna go that route, it might be feasible. I would imagine you have a camera, video, you know, constantly monitoring actually in the water to constantly monitor the flock properties, the size, how it's formed. And then with enough data, you would be able to basically have algorithm AI model to basically predict, oh, you have to reduce your shear force, right? You have to, reduce your pump, and oh, your water is too hard, too much ion. Then so that sort of probably be able to control and then direct to the dosage pump, right? So to me, that's very feasible in an application scenario. But I guess that's related to another question. Actually, it's right on the center front. Are we gonna be all replaced by AI, right, one day? So especially for the operating side, I think in realistic thinking, there'll be definitely fewer workers on the field. And then the people know how to use AI, probably have a higher job security. And But I'll give you one example. Now you reminded me. My wife has no knowledge of water engineering, right? So I told her like I do all this AI, this automatic tools for operation, and her response is, the plants you're working with are so stinky. Like, wouldn't that be good? There's no people in that plant. Nobody wants to be in those plants, right? That's a good thing, right? I think she has a good point. So, but anyway, that's it. But anyway, it's gonna help. It's gonna help. How do we actually manage over time? Like, how do we retrain our workforce? That's beyond my job description, but I think, well, yeah, our friend.
Well, you know, when you smell a well-run plant, you say that's the smell of money, right? So we've got some kind of one-off. So I had kind of put together as they had come in, but let's hit a few more, and I'll just kind of read these to you, and we'll kind of get them kind of one at a time. So AI tools for bioinformatics for looking at cross-species extrapolation of toxicity. Do you have any seen anything out there for looking at toxicity information and AI extrapolations there? Or is
Yeah.
there?
Yeah, it's a very active field. EPA is doing a lot on that. I can certainly point to you some researchers, Judy Zhang and Case Weston. So they're really looking into the chemical structures and the links to the toxicity. It's a very active research area on AI. Yeah.
Fantastic. Another question relates to kind of to students, right? So, and you could probably understand this, right? In one space, there are the computer science and computer and data analyst folks. The other side, there's environmental engineering. Can you talk to how you bridge across those fields? Do you kind of come in it to one and learn the other? Do you come in, what would be your advice there, particularly, I guess, also to professors or to employers when they're looking to hire people across the space? I mean, they're two very
Yeah.
separate fields almost. So,
That's a very good question. I have to say, it was one of the most difficult thing for me in the past few years was to find the students or postdocs that were able to do the work. That's why I'm very thankful to Junjie who was able to do that. So, like, I don't know about you, Dan, because I never had any training like this, right? So I learned by the fly. I watched a couple YouTube videos, right? So I guess that the fundamental side, I think a college is probably want to open some class, to train our civil environmental engineering students to learn such tools. I mean, we don't need to really be a master programmer or something. We just need to know our problems and how to find the tools and to train them or tailor them for our own use. To be honest, it's very hard to recruit computer scientists into our domain because we pay probably, I mean, half of what they generally get paid, right? So, but it's better to train our own, I guess, students and postdocs to learn the tools and to equip ourselves. That's probably a more feasible way. Yeah.
I imagine the computer scientists want to figure out how Wall Street works because probably more money to be made there than
Yeah, that's a reality. I don't blame them. So
No, of course. So a couple of more specific questions. So ethical issues of copyrighted material and AI, right? So so how does that work? I mean, and who does it belong to? And how do we, if this was kind of classic publishing, we would go back to our 20 references of where we got our ideas from. But if you're drawing from 30,000 papers, how do you cite the 20 references, right? So how does that work?
Yeah, that's a very good question. So I will not comment on how OpenAI and others access the data, but for us, that's a big thing that we could not really use the closed source books, right? So that's why we only use open source IWA books in our case, because we didn't want to get into the copyright issues. And also the model we develop is also open source and we share with everyone. So there's actually basically two competing models, right? If you look at Facebook, Meta, sort of they have the Llama series, right? DeepSeek, like open source models, everybody can contribute and use. And there's a closed like OpenAI and the Gemini model, right? So that's yeah. When you develop the model, if you're a utility, you develop a model using your own data. I think you certainly have the ownership. If you hire a company to do that and use your data, well, you have to negotiate who owns that and copyrights and other things. Yeah.
I can just imagine an AI model for each textbook that comes out, kind of like the way we get a set of in slides or textbook for the instructor with the answer key. There might be an AI model that goes with a textbook that you can use or so. It's almost what your WaterGPT is kind of in that domain space. So
Yep, probably.
along those lines, with respect to professional engineering, especially liability. So where does the liability of the professional engineer start and stop when they're using one of these tools, right? And part of this maybe relates back to the conversation you and I were having about, do you treat it as a person that you develop some trust with, right? But if I'm the engineer of record, I'm still responsible no matter who my colleagues are. So how do you fit AI into that professional liability space?
Yeah, that's a good question. So this is a very similar question. If you have a PE license, you have to stamp it, you're personally liable, right? I mean, same as a judge or as a doctor, right? I mean, they use a lot of tools, like say imaging. The doctors look at your X-ray, then they have to sign off. So at the end of the day, it has to be the human taking the legal liability in that. So AI will never be able to do that, right? I mean that. So we have to be the last, I guess, checking point on that to verify everything is okay. Yeah.
And certainly in publishing, we're all seeing that, right? Adding our little AI statements.
AI cannot be an author for sure.
Right, right. One final one before we get into kind of giving people some advice, right? So how is AI code written compared to other traditional codes? I imagine somebody's thinking Perl, Python, C, Fortran that you and I probably took back in the day. How does it look like to code in AI compared to other coding?
It's a life-changing experience. Right now, you don't need to know how to code. You just tell what you want to do. It's generally pretty good code for you. And I'm not again active programmer myself. I hope I can. Cloud is probably the best AI language model for coding. That's been known. Yeah.
Perfect. And along those lines, and kind of our final question, right? So there's going to be folks out there, right? We see those ads that they pass across my Instagram feed. I'll admit it, I'm on Instagram, and it says, "Hey, are you over 40 and you don't know about AI? Do the 30-day challenge," right? So how do people who say, you know what, I haven't learned anything about it, it's moving really fast, what would be your advice to them? Should they go ahead and jump into it in some way, and how to, and what would they do? And
That's a good question. I actually started on my own experience. I knew nothing, right? So YouTube was my best friend. It's all free. Take your time. You can listen. You can watch anytime. You don't need to pay for classes. I don't feel that's more unless it's very specific tool. So yeah.
you just got us both in trouble, my friend, for our universities that are going to try to make money on it. But yeah, there's a lot of YouTube, and don't you feel also maybe just some trial and error, kind of you said?
Absolutely. That's a great point, Dan. Just use it. You'll get better. Yeah.
Just use it. Any final words of wisdom you'd like to leave our audience with?
Well, first of all, thank you all again for spending time with us, and this has been fun. I guess the finishing word is I feel very excited by in the past few years by learning all these tools. It's opened up many doors for me, and I hope you can just give it a try. Yeah.
Thank you, Professor Ren. We appreciate you.
Thank
Over
you,
to
Dan.
Marissa to finish this up.
Okay, thanks everyone for all your questions, and thank you to Dr. Ren for sharing your knowledge with us today. We have several webinars planned in the near future, so you can go to aaes.org/events to reserve your spot. And just a reminder, if you're not yet a member and you're considering joining the Academy, please email me to discuss our membership options. For all board certified individuals, PDH certificates for this event will be sent out by the end of the week. That's all for now. We enjoyed being with you all today. Thank you so much and have a great day.